And okay, good. So when I say location, what do I mean, guys? What did we learn from this today's meeting? I mean, what do I mean, guys?
What?
Tell me.
Uh,
Yes.
Oh, I think
what? What?
I think you mean meters.
Mr. Teacher, what's a log?
Longitude, latitude, guys.
Oh. Ah.
Okay. So
Can
that's
you?
what the location.
You wrote lat twice.
Huh?
Like you're saying, lot is not okay. It doesn't matter.
Okay, you art major. You fucking do the diagram after I show you the actual information, okay? Um
Okay.
Don't get kicked out of the art program, okay? Why is it so small?
Golly.
Golly. That's a tiny font size, man.
Accept my friend request.
Microscopic.
Who's this?
My name is a boo boo.
Ah ha. Ah boo boo.
Invite me to the server.
Okay. So now I'm explaining. First we get the location, and then this is the part where yesterday's talk with Nathan comes in my mind, okay? So Nathan said a really important thing. The moon doesn't fucking change that much. So we know, let's imagine that we have the map of the moon. Okay? The whole fucking map. Limitless. Everything, right? Um in enough detail to dodge craters and all that, which allows us to figure out using the lat and long to run through a pathfinding algorithm, not navigation, pathfinding, right? Because navigation algorithms are only when you don't know anything, but this is fast. Fuck my writing, guys. I hate myself. Pathfinding, right? Um, so we run the pathfinding algorithms based on the maps that we have from Dust's documentation. This is the part where I am building an app to do this part and try to figure out which pathfinding algorithm is the best. Okay?
Okay. Okay.
This is the app that I'm doing. This is the part where it's gonna help us. After that, after we do that, after we generate a path, I want you guys to imagine this. Now, so imagine this box is our map, right? I'm gonna make it blue. And since I did a pathfind, so let's do purple. This purple shit is the LTV. This thing is the rover. And let's do the green thing. And then let's say this green. Huh?
No, I don't. Can one of you give me the suits role? My alt account.
Uh,
I don't have permission to do that.
can I at you
I
into
don't. I don't either.
Shit. Yeah, I can't change rules or anything.
Oh.
It's okay. Don't worry about it right now. Just listen to this. Okay. So now we have a creator, right?
Continue.
So our pathfinding algorithm, what's it gonna do? If the crater is big enough and noticeable enough in the elevation, it's gonna find the shortest path. Right? This is what our pathfinding algorithm is gonna draw. So this is drawing. We didn't travel there yet. Okay? Keep in mind, guys, we didn't
Yes.
travel there. Okay. So what we're gonna do is we're gonna use what Abby and Nathan comes up with to use as our local pathfinding thing, where we're gonna have small shits on the road, right? Some like this, multiple, right? And then
I
Oh.
didn't need this.
Mm.
I
Mm.
fucking didn't give any.
A large
Mm.
Huh?
What?
What did you say, Abby?
You're speaking in binary.
my question is, do we need a separate algorithm? Because I don't know if we do.
We do. That's what I'm
Like,
explaining right now.
continue.
Yeah. So this is the orange one right now. The orange yellow looking line is the pathfinding algorithm's output for the best path. That takes account the elevation and then the slope of certain roads to find the best path, right? That we know about from the map, the moon map. However, the bigger the quality of the moon map, the better it is. We're gonna use the biggest one in the competition and try to figure out from there. That's why we're gonna find the fastest algorithm too, right?
Yeah.
And from there, what we're gonna do is we are going to travel. Like Abby and Nathan is gonna come up with a way to go around these small things that gets on the road, but initially they're gonna be following the same line, like the same general line, but dodging the small rocks or the
Oh, so is
small
that where the
things.
best fit thing comes in?
That's where
Yeah.
this is where the lidar comes in. LiDAR comes in, right? With the PR, and then we hope that PR will get to the last known location of the LTV. After that, now, so the mission we got done a part of the mission, right? So now this is the second part. So I'm gonna draw a new map. Uh, this is the same scenario, just continuing. Where did my colors go? Here. Um, and then we will have, for example, let's say the last known location of the LTV is here. This is the last known location of the LTV. But actually, the stupid fucking LTV is here. Actual location of the LTV. LTTV. I'm just gonna do that, right?
Mm-hmm.
And our rover is gonna travel, right? Got to the last known location of the LTV using the path that we generated with the pathfinding algorithm. But now, this is all luck, and this is the part we're gonna have to figure out an algorithm. There is a range from the last known location to the LTTV where they say it's like 500 meters. 500 meters. How do we search a 500-meter radius from this location? So we have multiple ways, right? So we create a thing around it, right? A 500. Let's make this 500. Okay, so this is a really good example now. So this is in the middle, right? And this box, the mission box can be bigger, of course. Okay. So now we traveled and we got to it. I'm just gonna connect the lines here real quick. Okay. The last known location of the LTV, there's 500 meters radius, right? How do I find the gray LTTV? So after we get to the last known location, I think was it 50 meters, Abby? The beacon?
That's the thing I don't know.
Yeah, but let's just imagine that it's like 10 meters or something, okay? So you guys gonna do some research and figure that out, or ask NASA. So after the beacon can search 10 meters radius of the rover. So look at this, guys. Did we find the LTTV? Is it inside that circle? No, we didn't. So we have to find an algorithm. So what the Minecraft guy was talking about was that we go in spirals. So we did this. Now, imagine that since we're here, we go around like this one time, right?
Mm-hmm.
And then now we go around this one time, right? Around the parts that we didn't go through. Now we do a circle like this.
So
So now,
while you're doing that search radius, you're utilizing the lidar algorithm to navigate as you go about the radius as you're searching?
yes,
Okay.
yeah, you guys gonna have to do that. But my idea is that we cover all the area. So like,
So
it would be terrible if the LTV was like between
s-
two circles and we missed
yeah.
it because we decided to dodge a rock.
So my question about
Uh,
that is, so you have like this giant search radius. You haven't plotted a line in consideration of the topography. Like there could be a random crater in this radius. You could just be driving straight into it. You know what I mean? Like maybe you'd have to still use both of those algorithms that you mentioned to plot a line of best fit as you search around. I don't know, cause
yeah, you can do that. You can do that.
but you would
But
be
the main idea here is that since we don't know where the LTTV is, um, even if I do some searches and like generate like a path to search the radius,
mhm.
it won't be like amazingly correct and find the
Yeah,
LTTV. This is why I'm explaining my concern that like let's say we use the algorithm and it's searched, but there's like gaps in the search and we couldn't actually cover some areas. That's just a time waste.
yeah.
So, for example, in this definition here, since we are getting close and we are in the radius and we know in the radius, by default we search these places already when we get
Okay.
to the last known location of the LTV. In my like mind, we did this already. Like, or you don't even get to the last known location of the LTV. As soon as you realize you're in the 500-meter radius, you can just do this and start running around in circles
Mhm.
trying to find where the LTV is.
I see. I
So this
just
is the part where you guys can decide on like how to do this, and it will just
mhm.
travel. And then now, since I'm done with the outer circle, I will get to the inner circle, which is what I was doing. It's just the opposite.
Mhm.
Instead of going now, this is just doing the inside. So in this case, you would find the LTTV faster because that's the first thing you're doing, going to the outside circle.
Mhm.
Right? If it was going from inside, you were gonna find it last.
Yeah. It's just
Uh, so if there is any other data that we know about the LTTV that we can drive from, like fuel, for example, if it doesn't have fuel, it probably is max dead around somewhere here because that's like the 200 meters it can go with that amount of fuel, right? And then we would only search
oh, I forgot about
that
that part.
radius instead.
Yeah.
Yeah.
We're
So
we're consuming
those
a
are
lot
the
of
details.
sorry, we're consuming a lot of power when we're doing this. I just forgot about that. When we're searching this area. I don't know if that we have to take that into
Yeah,
accountability.
I don't think you can. No matter what, you're gonna have to solve the thing. From what I remember and from what the NASA people said, you just have to get to the fucking LTV. Like you just have to
I
find the
see.
LTV. Like it doesn't have to be the best path. This is just because engineering masturbation for me right now. That's how I fucking put it. Um, yeah.
Okay.
So this is how the mission is laid out in my mind. This is what I see. Like when you guys say navigation, this is exactly what I see in my mind right now.
I see. Okay. Um, got it. But yeah, so yeah, it's running on two
I have
algorithms.
a
So
couple comments
Hmm?
slash concerns.
All right.
What?
Makes sense.
Um,
Calculate path, drive around the path, and then once you get to the radius, search in spirals.
So yeah, like one
I just,
algorithm basically utilizes only the topography to create a line around like large geographic obstacles like a crater or a
yeah.
mountain, and then
Uh-huh.
and then yeah, past that line, and then as you go
Yeah.
about the line, use a different algorithm to avoid the smaller otherwise like unnoticeable
Mhm.
to the topography map obstacles like boulders and small rocks. So
Okay,
that's the plan.
that makes sense. That's a good plan.